Hello everyone, I am Rajeshwari. I am gonna explain about our project which we have done in IBM Cloud Platform, and our project is IoT based smart crop protection system for agriculture. Let me explain you in detail and we can move on to an introduction. As we all know, nowadays the crops in the fields were devastating by animals and birds, which leads to low productivity as well as the financial issues for farmers. So we have created an application which is an intelligent crop protection system. And as I mentioned you in first line, this system also helps the farmers to predict the animals and birds by using OpenCV image processing. And not only this, the farmers are in need of knowing the temperature, soil moisture and humidity levels too. So this system also helps the farmers to monitor those things. And the motors and the sprinklers in the fields can also be controlled by our applications which we have created. Move on to the next page. The main objective of our project is to increase the productivity and to protect the crops from animals. And this is then block diagram of our project, and the main aim of the project is to detect the animals and birds. Once it detected, it sends to clarifier service which can detect whether it is an animal or not by the image it captured. The image it will store in an object storage, and the image URL of that image will store in an cloud and database. And the next IBM Watson IoT platform which acts as a major role in our project, and it acts as a mediator between the IoT device and web UI. And web application is created to see the soil moisture, temperature and humidity levels. And this Node-RED, it is an online platform which we can connect all those sensors and motor on off all the buttons which to check the humidity and soil moisture and temperature levels. And these are the block diagram of our project. These are the techniques and procedures we have followed to build our application, and the first one is in Python script, and Python script is used to connect the cloud object storage and cloud database to the IBM Watson IoT platform as I told you in the block diagram. And this script helps to generate the random values of temperature, moisture and humidity, and it also helps to connect the clarifier service as I told you earlier, which is used to detect the animals and birds. And after following to that, second one is an IBM Watson Cloud, and we have created an account in an IBM Watson Cloud platform. Let me show you the page. And this is the page which we have created already in the cloud platform, and it is helps in order to connect our Python script to get the random values and to connect with the Node-RED to get the required output in the web UI. And in IBM Watson, we have also created a device which they will provide as an unique organization ID in which we can stimulate our device. And we need to create a device ID and wanna connect with a Python code. While creating, you will get an unique device ID, device type and authentication token which need to be noted in order to given in a Python code. And the crucial thing is that an authentication token is an irrecoverable. So while creating, copy all those things in a notepad or something else. You should also create an API key in order to connect with Node-RED, and these are the ways to connect API key. Look at these options after devices. See, there is an options called as an application. So you need to create an API key and API token which they will provide you as a random thing, and you should copy it or note it in order to use it in coming steps. Further on, after creating IBM Watson Cloud and API key in an IBM Cloud, and we should also create an instance in a cloud object storage and cloud and database. And cloud object storage is to store the image from the clarifier service, so need to create an account in that place. And cloud and database in order to store the URL of the image which I have told you earlier. And after this, we need to create an account in a Node-RED. You can create a Node-RED in the IBM Cloud Platform itself, else you can create a local Node-RED in order to monitor the temperature, humidity and soil moisture level by seeing in Gauge. And after creating Node-RED, you will get an output in the Node UI. Likewise, and after creating and connecting all those methodologies, and finally we should create an web UI which is an MIT app developer, which is an applications of our project. We need to put all the data in an MIT app inverter in order to show our output as an application. and these are the methodologies we are following in our project, and let me explain you in detail. Next, we have created a Python script for monitoring the sensors in order to get the random values of temperature, humidity and soil moisture level. And here, look at this, we have given an information of our device ID, authentication code and device type, which we have created in an IBM Watson platform in order to connect our code with IBM Watson so that we can get the random values in the recent events. Wait, let me show you the recent events, and these are the events in which we have created in an IBM Watson, and these random values can also see in IBM Watson also. After getting the output, we will show connected in your IBM Watson platform. Look at this. As like I told you, when we have connected all our IDs and informations in the code, it shows it connected in the IBM Watson. And look at this. These are the outputs we get in our Python code. After all this, we need to create a Node-RED service, which I have told in my methodology. As per my methodology, Node-RED services are important to connect the sensors, and in this we should install certain packages like IBM IoT, Node-RED dashboards in order to connect our palettes, which we can get from in Node-RED itself. And here look at this IBM IoT, and IBM IoT is in the sense in what we need to give an authentication code and all the keys which we have created in IBM Watson in order to connect with an IBM Watson, so that we have given all the informations, and connecting the message payload and temperature node and temperature, humidity, moisture, all those things to get the temperature and humidity, moisture. After this, in downwards, we have creating an HTTP functions in order to off and on the alarm, which we have created in the Python code. After connecting all those functions in the Node-RED service, it will be directed to a Node UI in order to display the output. And as the output is displayed, the alarm on and off, which we have created in a Node-RED services in order to give monitor the moisture level, temperature and humidity level. While we owning the alarm, it will shows the random values which we have given in a Python code in an IBM Watson, and while offing the alarm, it will disconnected in an IBM Watson and stop to run in the Node-RED services. And these are the Node-RED services which we have created in a local node application. After all those things, let me show the full Python script which we have created. First, I have shown the random sensor detecting Python code, and now I'm gonna show an overall Python code in which we have connected all clarifier services and cloud and database and cloud object storage in Watson and Node-RED and all together. And this is our Python code, and these are the packages which we have imported in order to run our program. And first of all, we have imported CV2, which process the video, and we have imported an IoT IBM platform WIOTP SDK device, and we also imported an IBM Watt O3 in which process the image which we have uploaded, and from imported Cloudent in order to connect with an Cloudent in an IBM Watson. And we have imported an clarifier services in order to detect the image. And next, the create resource, it is also in order to connect with an IBM Cloudent database and an object oriented database, and these are the credentials. And further on, and these multi-part upload commands are used to implement the image which we have stored in a Cloudent database. And to upload the image in a Cloudent database, we need a bucket name, item and file path. So we should be created those things in a Cloudent database. In my command callback functions, let me click the web UI. It will shows the command which we have given in a JSON format. If the command is received as per my command, it will shows light on or off, motor on or off in my Python code and in my output too. And these are the commands. As I told you earlier, in order to connect with an IBM platform, we have given all our informations like organization ID, type ID and device ID and authentication token in order to connect with an IBM platform. In here we have creating an sample database in which For our acknowledgement, we are giving and successfully created to print. If the database are created, it will print and successfully created. And here we have given and got an MP4 in order to check the animals movement as our project motto. And here the process which will be detect the animals movements or not. It will check the frame by frame and process the image and send to the clarifier service. And here model ID and all the credentials which we have created in a clarifier service, and those are the credentials which we have used in our Python script. If there is no response from the clarifier service, then it will shows that the detect is equal to false. And if detected any animal movements in a clarifier service, it will respond with an concept value like 0.98, which we have shown in my Python script. If the correct concept dot name is equal to animal, then it will print an alert animal detected, and it will give a voice like an alert. As I told you, it will play sound using an alert.mp3 in order to detect an animal's movement through and play sound, and it has created in a text to speech in an IBM Watson platform in order to give a command through and play sound. And if the animal is detected, as I told you earlier, it will show us that detect is equal to true. Then moisture and humidity random values which we have given as an input in order to detect the random values. And next, my data is equal to animal detect moisture. It will store all the information in the cloud and database, and will shows the data. Here command callback function is used in order to detect any command is received or not. If any command is received, it will call off all the functions which we have implemented in above steps, and it will call off all the command functions. And then if any keys are pressed, and it will disconnect in an IBM Watson platform. And that's it. It is an overall Python code which we have built to in order to get an applications for our system. And this system helps the farmers to monitor the soil level, humidity level and temperature level. And by using this overall Python code, we can build the applications for our crops betterment. And thank you all. This is our project, and let me complete it and finish it. Thank you so much.